Very good evening friends, and in this video we are going to discuss about the differentiation using the first principle at a given point. Like the last video you just saw that we found the differentiation of a function at any point using the first principle method or the ab initio method, same thing, only the name suggests differently. In this video we will be applying the same method as first principle method or the ab initio method, but we will be trying to find out the differentiation of a function given at a particular point. So like if we have a function fx and we want to find f dash a, means we are finding out the differentiation of the function at x equals a. So the ab initio method says that f dash a is limit h tends to 0, and there you write f a plus h minus f a over h. This is it. This is again the very same concept of the limit. For example, suppose if I say that if I have to find the fx of x cube plus 3 using this method at x equals 2, then how you do that? You just write here f dash 2 is, we need to find f a plus h, that is f2 plus h. So this will become limit h tends to 0 f2 plus h. First I write 2 plus h minus f2 upon h. Then here limit h tends to 0 f2 plus h means replace x by 2 plus h. So this will become 2 plus h whole cube plus 3 minus f2, so put again replace x by 2, that is 2 cube plus 3 over h. Now this one becomes, let me draw a separator. So here this is limit h tends to 0. Now this plus 3 and minus 3 cancel each other, so we just have 2 plus h whole cube minus 2 cube over h. We can write this as limit h tends to 0, a plus b whole cube is 8 plus 3 into a square b, so 3 into 2 square h is 12h plus 3ab square, so 3 to the 6h square plus h cube minus 8 cancel, and you see each term necessarily have one h. I can take that h common, and then I will have 12 plus 6h plus h square, h common over h. This common taken h is cancelled by this h. So now limit h tends to 0. Now in this case we can put the value of h directly as 0. So we will get 12 plus 0 plus 0, that is 12. So this 12 is the value of f dash 2, means the value of the differentiation of this function at x equals 2. So this is how you can find the value at given points. Now I would like to solve another example. For that I need to just take one more. I need to clear the screen first. Okay, now suppose if I am interested in finding out the differentiation of a function fx is x square sine x at x equals at x equals 0, then what will be the answer? Then we will be having first definition, that is f dash 0 is limit h tends to 0 f0 plus h minus f0 over h. So limit h tends to 0, f0 plus h is 0, just like h. So here this will become h square sine h, and minus f0, so if you replace x by 0, this value is just 0 over h. Now 1h cancel this, so limit h tends to 0, this will be just h sine h, and Sine h, this may give you different value, but 0 into anything is 0, so this answer is actually 0. This is how you can find the differentiation of the given function at a given point using first principle or ab initio method. So now I would like to say that you might have heard that the differentiation is done using the formulas also. We have various formulas, and then how these formulas have come up. So let me explain you just by cleaning the stuff. So ab initio method is a very lengthy method and cannot be used every time. This is very time consuming. So we will use formulas. Like I just tell you one formula which goes like d by dx of x to the power n, is differentiation of this exponential function x to the power n is n x to the power n minus 1. This is the formula. Now we are just trying to find out, derive how this formula have come up. So again we'll be using the ab initio method. So we write f dash x is limit h tends to 0 f x plus h minus fx over h. So limit h tends to 0 fx plus h, at this place if you write become x plus h whole to the power n minus x to the power n over h. Now this is limit h tends to 0 x plus h whole to the power n. This is a binomial expansion. It goes like nc0 x to the power n plus nc1 x to the power n minus 1 h plus nc2 x to the power n minus 2 h square plus, I just write the rth term directly, plus ncr x to the power n minus r into h to the power r, plus directly I go for the nth term, this is ncn h to the power n, and then we have this minus x to the power n over h. Now this nc0, those who have studied combination says that nc0 is the combination of 0 things taken out of the r things, and the formula for the ncr goes like factorial n over factorial r, and this is n minus r factorial. So nc0 will be n factorial over 0 factorial into n factorial, that is 1, because 0 factorial is also 1. So this nc0 and ncn will also be having value 1. Same reason, n factorial over n factorial into n minus n factorial, that is 0 factorial. So these two numbers are same. So what I say that here nc0 is 1. So this becomes x to the power n, and this is already x to the power n. These two cancel each other. Now what is nc1? So nc1 is n factorial over n minus 1 factorial into 1 factorial, that is actually n, because n factorial is nothing but n minus 1 factorial, n minus 1 factorial over n minus 1 factorial, that is n. So these two cancel. Now here you see that what you are left with, every term from here to here, every term necessarily contains one h. So I take that h common, then I'll find nc1 x to the power n minus 1 plus nc2 x to the power n minus 2, 1 less h, because 1 h I have already taken common. So h square becomes h, and just I would like to write the last term, that is ncn is 1, and this will become h to the power n minus 1 over h. This h cancel this h cancel this h. This is your limit h tends to 0. Now you just can put the value of h directly, because this is going to be a defined value, it's not undefined, so you can put the value directly. So put h as 0. So now this term is 0, and every term after that all will become 0. Then what will be left? You'll only left with this one, which is nc1 x to the power nc1, and that is, what is nc1? This is n, so this becomes n x to the power n minus 1, and this is your f dash x. So these formulas, all these formula, now you say that differentiation of sine x is cos x. How have this come? So the only answer is that using ab initio method or first principle method. Now this is how you can derive all the formulas. We cannot derive all the formulas here, but at least if you feel like knowing how the formulas have come up, if you have time, you can spend some time working over different functions using the formulas called, the method called ab initio method or the first principle. You can find all the desired results. Thank you very much. Just subscribe to our channel and keep learning with us.